Okay, gang, so continuing on with our talk on community ecology, one of the things that you'll notice when you have multiple species living together is that they're always going to interact. And so we've defined some basic ways in which different species will interact with each other. And one of the ways is non-competitive interactions. And that may sound a little interesting because we keep talking about competition and how things want to remove competition, but some things have learned so well to not compete that they actually work together. And so we call that symbiosis when different species of animals work together for benefits. And there are two basic types. One's mutualism, where both the organisms will benefit from the interaction. And there's commensalism, where one benefits from the action and the other is not benefited, but it's also not harmed. So, an example of mutualism, let's say, so here's a water buffalo, and on its back there are a bunch of birds. And you can probably imagine that they don't weigh much for this water buffalo, so they're not really hurting him. But what are they doing up here? Well, if you think for a minute, you'd probably realize that there's a lot of flies and insects that would love to feed off of this water buffalo. There may be even ticks and fleas and mites on him, and some flies buzzing around. And these birds will eat those, so they're getting a meal, and the water buffalo is getting depested. Uh, if that's a word, it's getting all the ticks and fleas and mites removed off of it. So he's benefiting by getting a cleaning, and they're getting a meal. So that would be a mutualistic relationship, a type of symbiosis where both are benefited. Here we have another type of mutualistic uh, uh, symbiosis where we have this is a crocodile, and it's gone up on the shore and it's basking. They don't have sweat glands, so they actually keep their mouth open and pant, kind of like a dog does, to help regulate their body temperature. And this bird, well, I don't know. Maybe he just wants to feed the crocodile, but no, that's not what's happening. And I think most of you know that this bird is actually picking some of the bits of flesh, maybe some parasites, um, and giving the giving the crocodile a teeth cleaning. That is a benefit to the bird because he's getting a meal, and it's a benefit to the crocodile because he's getting he's getting healthier teeth as a result of the bird's actions. And so that is also a mutualistic relationship. Commensalism's a little bit different. I don't have a really good picture of it, but if you've ever seen cowbirds walking next to cows or next to bison when they're grazing, the cowbirds don't actually sit on the buffalo. They don't actually sit on the cows. They're off to the sides. So as this large bovine moves through the grass, it disturbs the grass, and insects scatter to the right or left of the cow or to the buffalo. And as they do, well, the cowbirds see them moving and can run up and pick them off. It's beneficial to the cowbirds, but it's not hurting or helping the buffalo. They're really just kind of indifferent to it. So they're getting the birds are getting an easy meal, and nothing's really happening to the bovine. That would be a type of commensalism, a type of relationship, a symbiotic relationship where one is benefited and the other is not harmed at all. Usually when we see organisms have symbiotic relationships and they are closely linked to each other, we see a type of a relationship called a coevolutionary relationship, where the evolutionary changes in one of the species promotes an evolutionary change in another species. As our example, and I've used this before with some of our evolution talk, is the shape of this flower and the shape of the bird's beak. Now, the flower is a big food source for the bird. And as the shape of the flower changes, it promotes a change in the shape of the bird's beak. Birds' beaks who naturally curved to the way the flower changed were able to get more nectar without harming the flower, and that was more beneficial, so nature selected for those particular characteristics, and over time we see the shapes kind of match up. This is pretty big with flowers and insects. There's a type of orchids that actually almost mimics the coloration and size and shape of a female type of wasp. And so the males think it's a female. They go down and try to pollinate with it, and they end up getting pollen all over themselves, and they just fly off to the next female. They didn't actually mate with anything because it was an orchid. It was just a flower. But that's the type of cool evolutionary relationship. And we see these when we see that two different species are closely intertwined with each other. So if you have non-competitive interactions, you can imagine that you're going to have competitive interactions, things where a competition is key. And there's two different types of competitive interactions. There's intraspecific, which is between members of the same species, and there's interspecific, which is between members of different species. So you can imagine here that these two rams, I think most people know that when these guys get to be sexually mature, they'll start fighting for territory, fighting for mates. There's probably a lot of posturing that goes on prior to them butting heads because that's a dangerous activity. If they can size each other up and determine which one's going to win without actually having to have conflict, they'll do that. But in this case, maybe these weren't able to resolve their differences. Maybe these are just two juvenile males practicing, though they look like pretty full-grown adults there. Then competition will ensure. And it's competition between members of the same species, so it's intraspecific competition. With interspecific competition, we have competition between different species. Now, there's tons of grass in Africa and the Serengeti, and that means there's tons of herbivores there. I mean, you start on the Discovery Channel, you see 10,000 heads of zebra and wildebeest and Thompson's gazelle all running around together, and there's tons of grass for them. You would think that these top predators would have plenty to choose from. There's a lot of resources. They wouldn't actually conflict, and they wouldn't actually compete with each other. But what's easier, bringing down your own prey or stealing the prey that someone else has brought down? So we all know from watching Lion King that hyenas and lions actually do not get along all that well. They actually will steal each other's prey pretty readily. Lions do this to hyenas. Hyenas do this to lions. So there's a lot of competition that goes on over the ease of getting those resources. But keep in mind, in either one of these situations, either an intraspecific or interspecific competition, you're always going to have a winner and you're always going to have a loser. That results in something we call competitive exclusion, where the winner gets the resource and the loser does not. The loser then has to go someplace else. So if they survive, that is, they have to go someplace else to get the resource. It may not be far. It could just be over a tree or two, or it could be just around the bend, or it may be a couple miles away, wherever that resource is, and they have to go there to get it. They've been excluded from what they were fighting for. And that results in a concept we know as resource partitioning, to where this guy won, so he gets the stuff that's here. The loser goes over here and battles again, and if he wins, then he'll get the stuff that is here, right? And he doesn't go over here to where he lost earlier and try to start up competition again. No, he'll stay there where he won. And that is kind of like its own little space, kind of like the ideas of those niches, those jobs where they don't overlap. Remember, nature is always about reducing competition, reducing the need to fight and over resources. And so when they do that, we end up seeing this resource partitioning, to where this is your part of the resource, that's my part of the resource, here's my resource over here, here's your resource over there, and so forth and so on. But they don't overlap. And again, with the idea is to reduce competition. So when we see resource partitioning occurring, that's always the result of some type of competitive exclusion, where there was a competition and the loser was excluded, had to go away. So here we have a picture of some resource partitioning happening, some competitive exclusion going on. We've got three different species fighting over a resource. In this bleak wilderness where it's nice and cold, not a lot of prey going around, right? Not a lot of stuff to eat. So you've got this carrion down here, this dead animal. It looks like a golden eagle, a fox, and some type of bird are fighting over it. Well, it kind of looks like that golden eagle is kicking this guy's butt. And you could probably imagine that this fox is not going to get this carrion. He's going to be competitively excluded. When he does, he'll leave and go someplace else. And when he finds something else to eat, he'll may have to battle for it. If not, that's his area now. That's his resource. And that is what we call resource partitioning. So anytime you have competition, you'll have a winner and a loser. That's competitive exclusion. The loser has to leave. When we look at the bigger picture of that, and you have all these little spots where here's my territory where I've won, here's your territory you've won, and here's this other person's territory over here where they've won. That's resource partitioning, and it's the result of competitive exclusion, which is the result of any type of competitive interaction. So another good example of resource partitioning, a study was done back prior to 2007 of these warblers all feeding off the some type of conifer tree. And the conifer tree was broken down into sections, and it was recorded where the warblers were and what warblers were in those sections. Turns out that the Cape May warbler only feeds from the top outer portions of the branches, whereas the bay-breasted warbler feeds from the middle, interior, and exterior branches, a little bit up and a little bit down. And then the myrtle warbler feeds from mostly the bottom branches, but when it gets the opportunity, it will go up and feed from a little bit maybe from the middle, a little bit maybe from the upper outside. But for the most part, if you look at just the K-mate warbler and the bay-breasted warbler, they're never going to interact. Their resource partitioning has completely removed any competition. And that's the way we want it, because that's now safe. You're not going to have to compete with some other species for your breakfast. You may have to compete with your own species because of that intraspecific competition, but you won't have any interspecific competition. But the myrtle warbler, well, you can see he does spend a little bit of time. Every once in a while, maybe when the bay-breasteds are gone or taking a nap or something, he may jump up here. Same thing, he may jump up here for the Cape May warblers and go into some other area when they're not there. But for the most part, he feeds down the bottom inner branches. And again, this is all resource partitioning, the idea that we're going to remove as much competition as possible and remove the risk and remove injury by dividing out where they're going to feed from.